But nonetheless, we'll try to do our best. What I'll try to do at least is to basically show you the feel of what AI is beneath the hood. To a certain extent, it's like showing you the door. But to really understand AI takes a lot of effort and practice, I would say. Practice in the sense solving real world problems will give you the real view of the insight of what AI actually is. It's basically got to do a lot with mathematics. It's understanding the real world problem, trying to formulate the real world problem. That is the biggest challenge. Primarily, most of the people get stuck at this point where they think if they know languages like Python, they can rather solve problems pertaining to AI. Python is just a programming language, but the bigger picture is to understand the problem and formulate the problem mathematically. You might be interested in visiting Stanford University and try to Google trying to mathematical thinking by Stanford. Try doing that on Google. You will probably find a couple of papers written on mathematical formulation. Now, that's the biggest challenge. The challenge is to primarily understand the real world problem, and that takes a lot of time. 80% of the challenge that primarily data scientists or people who are doing research in AI have a tough time identifying the problem and mathematically formulating it. That's the biggest challenge. Remember when we were kids in school, we used to have this word problems where, we used to get this word problems. And I remember I used to struggle with that because it was in English that we were not used to it. The product of you used to have problems like the product of two variables x and y equals to so and so, but their sum is equal to so and so. Find the value of the you know variable x and y. So these kind of problems is something that we used to see in our school days. uh, but the real world problems that we face today, pertaining to AI, would be, exponentially larger. And understanding the problem in its entirety takes a lot of time. And when you start understanding the problem, also knowing the data that is relevant to the problem is also so important. So we'll try to brush up some of the concepts at a high level. Since I think only one person had raised his hand, I guess most of you might have not been very familiar with what AI can actually do and how it does within. I'll try to cover the concept of today's topic, which is trying to understand neural networks within the hood. But before that, let me uh, brush you through um, uh, share computer sound. And okay, let me brush you through some of the basic AI stuff. Okay, we'll start with the demo. And usually this is the demo I give because it becomes very easier for one to comprehend AI. Mm, okay, let me do a quick. Okay, let this try to identify this
Face
object.
detection algorithm initiated. Give me some time to train and identify the pictures I had earlier taken and let me identify who you are. It took a while for me to learn from the data. The GPU machine would have helped me learn faster. Nonetheless, I am ready to recognize. Don't be surprised if I mess up. After all, we all make mistakes sometimes.
Uh, Zoom doesn't allow, but I've used this on Zoom earlier. Okay, just a second. Just a second. Let me stop this camera. I'm trying to basically, I have trained this network with one of the images already, and I just wanted to show you how this algorithm works to identify
Face detection algorithm
that
initiated.
image.
Give me some time to train and identify the pictures I had earlier taken and let me identify who you are. It took a while for me to learn from the data. The GPU machine would have helped me learn faster. Nonetheless, I am ready to recognize. Don't be surprised if I mess up. After all, we all make mistakes sometimes.
Okay, you see,
Hello, Obama.
I'm a stranger, and if I bring Obama here, just a second, let me switch this. So, okay, 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 okay. It's giving stranger, stranger, stranger. Okay, let me do this. It's not
Sir,
able to.
can you lower the brightness, please?
Yes, it's got to do with the brightness. Just a second. Let me train the network with my face, and then it's got to do with the lightning. Okay, let me train this network on my face.
I am a machine and I need data in order to classify and identify. I am an algorithm that detects and identifies faces. Hence, in order to identify you, I need to take your pictures. Taking your pictures, give some expressions as told please. Look straight. Look a little toward your right, just a little. Look a little toward your left, just a little. Look a little upwards, just a little. Tilt your head a little toward your right, do not turn, just tilt. Tilt your head a little toward your left, do not turn, just tilt. Smile please. You did great. You have an incredible smile. Keep smiling and have a nice day.
Okay. Now you saw that we trained this network um, with the data. And this is the database that is created. I have data of Obama, but it was not able to recognize because of some lighting issues. And this is what we just trained the network with. So we are training a network with these images. And I'll get on to how the network trains itself when we start discussing neural networks, which is the topic of interest for today. So how a machine learns is something that we'll try to focus on. So, but this is the data, and we call this as a ground truth data. And once we've given this to the machine to learn, it learns in a certain way, which we will address later. And then once it has learned, then we'll run another algorithm, or we query the network to identify the face. Now, since it has learned my face, let us see if it kind of identifies my face.
Face detection algorithm initiated. Give me some time to train and identify the pictures I had earlier taken and let me identify who you are. It took a while for me to learn from the data. The GPU machine would have helped me learn faster. Nonetheless, I am ready to recognize. Don't be surprised if I mess up. After all, we all make mistakes. So,
Yes, I
Syed.
just distance. So it's Syed 64, 62, 60, 70. It's ranging in between 70 to 64%. If you see that, downloads Syed hyphen 64, 70. So that's the accuracy which this is giving. And if I bring Obama, it should recognize this. Probably it's got to do with some lighting issues. Anyway, so that's
Hello,
so if you see
Syed.
this, you also heard the machine speaking in the background, right? Uh, if you have heard, you can raise your hands in the chat box. Okay, thanks. So you've just seen that machines can talk, machines can identify people. This is a very basic demo that I gave you. The algorithm uses a binary patterns algorithm, which is not great. If using convolutional neural networks, some algorithms, advanced algorithms that are there on our phones already, which kind of unlock when they recognize our face, I mean to say. Those algorithms learn like this. So once you want to make your phone face unlock, you have to basically provide some expressions to your phone, and then the phone takes your pictures, identifies, learns how your face looks like, which is like feature detection, and then based off that, it primarily then goes ahead, and once it has learned, it will unlock your phone once you keep it in front of you. So that's the idea of how these things work within the hood. So there are two things that you need to take away from this basic demo. Is one, machine needs data to learn, and then once it has learned, again, the efficacy or the accuracy of the learning depends on the algorithm that you're trying to use. And in this case, I was using a very basic algorithm which is not very great, which is why we were having issues with the recognition and the accuracy was not high. But if you're using algorithms which are advanced, and uh, that is when you get high accuracy. And today we have AI which is having accuracies about 90%, which was not very uh, you know something that we used to hear 10 to 15 years ago. But now we do have AI with high accuracy, with deep learning. The machine just keeps learning more and more. The other demo that I wanted to also share was a single shot detector, to see if the algorithm can identify images that we see here. This is called a SSD, single shot detector. uh, I want to basically relate this to self-driving cars, where they identify objects on the road and can maneuver all by themselves. Of course, a lot of reinforcement learning has gone into it. We will touch upon that briefly in a while once we hit the PPT. But I want to start. I started with demos so that you get a feel that intrigues you of how AI actually learns. Now, these are a bunch of pictures that you see here, and we'll try to see if machine can identify these. Okay, so we will try to see if this donkey 2 picture that you see on your right side, can a machine identify that. So we will give these images to this algorithm. By the way, this model is already trained to identify these images. So the training part is already done. So we're just trying to query the network to find if this really kind of identifies what this image is. So we are giving donkey2.jpg, which is this. We have two donkeys here, probably presumably one is mother and the other is the child. And you see, it has identified the first donkey is to be horse, and the second donkey also to be horse. And okay, let me tell you, this bounding box that you see, this green boundary that you see, is the object of interest. Now, that is the first part in neural networks, particularly with images. You identify the object of interest in an image. So once you've classified that, it's basically a classification algorithm where you want to find the boundaries of the pixelated area that is of interest. Now, for a machine, everything is pixels, but then it has to classify what pixels are important. And then once it has identified the boundary, it will kind of create a bounding box, which is the object of interest for us. And then we'll classify what that object is. So in this case, it has messed up. It is showing like it's a horse. That is not correct. We'll move on to another. Oh, it also showed us cow, which is 26%, which is not right. We'll try to see if it identifies this donkey one at least. Okay, so probably it's not identifying that. Not a problem. We'll move on to example one. Example one in our case is these two cars. You can see it has identified this to be car 99.93%, 97.42%. So when you see this accuracies in form of percentage, you will get to also know that it's a matter of probability theory. So AI has got to do with a lot of data, which is your statistics, number one, and it's got to do with your probability, the Gaussian curve, as they say, or the bell curve. That's very important. You have to have your statistics, which means you have to have lots and lots of data. So once you have lots and lots of data, the machine will train accurately. In that case of the identifying donkey images, probably the images with respect to donkeys were less, uh, comparatively with the images that were there to identify a horse. And we'll try to identify a horse. The reason why I said that is if you train a model on a specific, you know, concept or data, then primarily it gives more weightage to that. We'll see that in a while when we touch upon neural networks. I'll actually show you why it does that. Okay, horses too. I'm trying to identify, this model is trying to identify this particular image. Horses JPEG, horses too JPEG, and then you see it's 100%. I've seen two participants raise their hands. Is it chat box not working? Okay, you have something to ask. If you have to ask,
Yes, so actually, you're querying this horse image. Actually, does this taking the data from the server or your local system?
I'm using OpenCV API,
Okay.
the Python API, and now this API is already trained on identifying certain objects like what you see on the screen. I'm just trying to query the images that are there that you see on my screen.
Yep.
So, but the model by itself is actually trained already. So it's not like we are training it from scratch. It's trained to identify objects, which is
Okay.
why I actually took you through the first demo where we actually trained the network and then allowed it to identify
So
us.
actually, this the API which is available in server, or actually you have created on your
You
own.
have to you have to download OpenCV, Python API, which is the model. Let me show you.
Okay.
You see this object detection deep learning.
Yeah.
Uh, you kind of just a second. You Where is that OpenCV? Okay. Let me show you. open CV. I need to find it on my machine. Where is it? Anyway, you can Google OpenCV,
Okay.
download OpenCV. Once you do that, you will get that bunch, downloaded, and that will have, these. So moving on to this demo that we were actually working on, let's try to identify a couple of more objects, and then we'll move on to this example 5, for instance. Okay. Okay, we have example 5. In example 5, we have lots of information. We have this, this example 5. We have a person, we have a horse, we have a dog, we have a car. Okay. It's identified a person with 88.44%, horse with 99.91%, dog with, it's confusing between dog and something else. Let me see what that is. Dog and cat. It's confusing between a dog and a cat. If you can see here on the screen, car with 99.43% accuracy. So in this particular image, we have multiple objects, but it's identifying those objects with a given accuracy. So if you have a self-driving car, this is how it identifies. This is a single shot detector, but the one that the car will use is primarily more to do with the first demo that we saw, dynamically identifying object at a given instance, and then trying to maneuver all by itself based on an algorithm. We'll try to end this with this particular example, horses 1. I have something to say there. You see, it was able to identify horse with high accuracy. Now, horses 1, we have a couple of horses, and primarily it's a front view. Let's see if this model is trained to identify horses with the front view, because most of the horses that we see here in these bunch of images are horses with the side view. So if this model has learned only horses to, with respect to these kind of images, then it might not work that well. So we'll see this. You see, it's not identifying, these. It's identifying this as a bird. This is a person. The accuracy is low. Bird 83%. No, it's identifying everything, person and a bird, but not a horse. So obviously, this network is not trained on images of horses of this dimension. So it's very important to know that you train your network with relevant data, so that when you provide it with unseen data, you also have comprehended that what that unseen data could be like. Otherwise, that network might not really classify or identify the object. So it's all got to do with training the network, and we'll touch upon neural networks, and I'll probably try to emphasize more on this. It's a machine. It doesn't really do magic. It's all about math beneath the hood, and how that works is it's what we're going to find out. So what we've seen so far in this demo is we saw machines identifying images, and we saw this machine also being able to talk. We have speech technology, we have object detection or image recognition technology. We also have natural language processing, where a machine can comprehend lots and lots of data, which I'll take you through. Now, Google is an example. I mean, if you Google heart attack, this is an NLP, natural language processing. Also got to do with speech. You have Alexa for that, which understands even Siri or Android phone, Android assistant kind of communicates with us with this NLP. You have speech. NLP is also relevant to speech, and also NLP is relevant to text, where the algorithms can read lots of documents and understand and comprehend some of the topics, what they are like. Like in this case, we give heart attack, and this is the bunch of results which Google will kind of provide. But if you see, okay, let me hide this. If you see, now this particular algorithm has learned a lot of documents to understand heart attack in its entirety. This is what I was supposed to show you. Now, this algorithm has learned heart attack and chest pain, coronary artery disease automatically, all by itself. It's an advanced machine learning algorithm. We don't actually provide data to it to learn. It's like we provide the raw data, data as is. We don't provide the ground truth data as we provided in the demo one and also in demo two. So in demo one, demo two, we had to provide ground truth data, but there is something called advanced machine learning where we don't provide the ground truth data, but we rather provide the raw data or unstructured data. And we don't provide any guidance to the machine, and it's up to the machine to decompose the raw data and come up with the concepts that are relevant to each other and cluster them. It's more like a advanced clustering algorithm. So this is what it does. Here it has clustered heart attack with these concepts or these topics that you see as related. And then it also brings in the second dimensional search space, which explains why these two topics are related, like chest pain and heart attack are related, because of these phrases that it found in many documents from MedicineNet, Mayo Clinic, and Yahoo, and you see these references. And then coronary artery disease. You see heart attack and coronary artery disease are related because of these phrases that it has come up with a bunch of resources. And cardiogenic shock, you see cardiogenic shock is a condition in which your heart suddenly can't pump blood to meet your body's needs. Cardiogenic shock is most often caused by severe heart attack. Now, this actually helps someone who is not an expert in a field for him to quickly identify and know how things are related, particularly in the field of education. So you see this. This is a machine that has learned on its own without any training data. So machines can comprehend, knowledge to a certain extent. This is something that couldn't have been perceived 20 years ago. And we now have algorithms that can read millions of documents. Like Wikipedia, currently the English articles, there are like 6 million plus. It's very difficult for a human expert to actually read all of them and comprehend all of them. So we don't need that. We need an algorithm that can learn those algorithms and comprehend knowledge and bring that knowledge to us. So which is why we see there's a lot of disruptive innovations in the educational space going on, and going forward in another 5 to 10 years, that will be even more disruptive, where we don't have to remember, we don't memorize, we rather learn, we try to understand, comprehend, because machines are better in bringing this up very quickly. So it becomes difficult even for a doctor to comprehend certain topics immediately. He has to kind of think through. I'm not kind of challenging, but I'm trying to basically put the fact across that machines are getting smarter and smarter. People don't actually understand this because they don't really understand how AI works and what it can do. But once you start understanding what it can do, you will get to understand that machines are capable of doing so much more, and they can be really used in certain things where they can complement the human experts to a very great degree, to a very great extent. So that is the importance of the AI in today's era, and that's actually also the fact. So this particular algorithm, as I also said earlier, has read documents on medical and without any guidance has understood how two things are related. If I can type another query, strabismus. So you see, it's amblyopia, Down syndrome, albinism. It brings what amblyopia is. Another form of lazy eye that cause amblyopia is called strabismus. Strabismus is most common cause of amblyopia. So you know how amblyopia and strabismus is related. Anyway, it brings in question and answers and OU definitions. It also can summarize the documents, machine summarizing a document. So we have this today. I mean, so natural language processing, image processing, or object detection, speech, we also have that. But what we don't have is logic. Logic is where the current trend is moving towards AGI, artificial general intelligence. It's all got to do with logic. We have the math, we are struggling with the logic with respect to AI. When AGI comes in, which is the next level of AI, you will see more disruption in in many domains because AGI is that much powerful, where you have machines trying to comprehend logic in a way that mimics human intelligence, and that is also a concern because AI currently is not regulated. I say that because these guys will. I always tell this, these guys will. You will see these robots coming up in another 5 to 6 years. We have these robots already. If you Google Boston Dynamics, you will find a bunch of robots that will run, jump, do stuff that a human expert gymnast can do. A robot can actually do that. That's the advancements that we've had with respect to gyroscope. The IMU devices, inertial measurement units, if you know this, I mean, these devices were primarily used in rockets and aeroplanes to stabilize and to basically know their orientation. So Google IMU, inertial measurement units. This device has become so profound that these were accessible only by governments earlier. I'm talking about 15, 20 years back. But now we have IMU in our smartphones. We have them everywhere and they've become very cheap. You have IMU devices which you can buy, which you use for stabilization. And since the algorithms pertaining to IMU have become so much powerful, like a Kalman filter or a complementary filter, to basically identify the orientation of an object and stabilize them. The gyrodynamics, the physics of keeping a robot balanced is mature enough for a rocket to launch and land on its own, like you see the SpaceX rockets launching and landing by themselves. So it's become so accurate. So a robot with those algorithms can easily stabilize. So the gyrocopters stabilize themselves in air automatically. So making a robot move, run, jump, do a somersault is not like a difficult thing in today's world. It's a solved problem. The unsolved problem, though, is the AGI, the artificial general intelligence, bringing that logic into this robot. We have the speech technology, so the robot can talk. We can have the learning ability, where the robot can look into the images or read the documents and understand, comprehend. But what is missing is the logic part. Now, that is what AGI, OpenAI, is working on it. I hear background noises. If someone has unmuted their mic, can you please mute it? So I was mentioning OpenAI is working on AGI. Microsoft and Facebook is working on it, and every company which is dealing with a lot of social interaction, like WhatsApp anyway is owned by Facebook. Uh, Facebook, Google, uh, all of these big companies that have lots and lots of data of how we communicate, that can be reverse engineered and used to train robots. So it's more like how a human understands things, how a human communicates things, how a human uh, uh, identifying his sentiment. It's called sentiment analysis. How does a human respond to certain situation, and how does he communicate or how does he argue on a subject? If that is all there on the web, which is already there, because there are a lot of chats that these people have access to, so there is lots and lots of data. It's just a matter of reverse engineering that and feeding that to these robots. It's more like building operating systems for robots, and you will have different forms of operating systems going forward for robots, and then you will have application softwares where you can program these robots to basically do cooking at home, to be used as a security guard, to be used as a cleaner at home, to be used as whatever. you know you will have different application softwares coming up. That's a future of where AI is heading.
I have a doubt, please.
So I spent a lot of time on this. I didn't actually plan to do that. So this is a high level AI tree.
Excuse
uh,
me.
Excuse me.
I have a doubt.
Go ahead.
Did this robot cause any damage?
Hmm?
Do this do these robots can cause any damage to household appliances?
Damage to
Household appliances.
household appliances. They can cause damage to household appliances because if the robot looks at something which is it is not trained, and something which is not comprehended while training or while designing, it might cause certain harm, which is why these things are not coming up in the market as quickly, because we have the hardware already there, but the software needs to be tested so much. Remember when we used to hear the news about self-driving cars, particularly the Tesla model. I remember to have read an article where it caused an accident, and actually a person died because of that accident, and that was caused due to this self-driving car. The Google self-driving car also got into an accident sometime back. I mean, this is like 3 4 years back, if I remember it right. I'm not really sure, but you can Google it and check it out. So these machines did cause problems, and that's true even with human trying to learn to ride a car, and then he unknowingly, or he comes into an accident. You're trying to learn a car, and then you know smash something up. That happens. That is also true with the human. So it's not very. I'm not defending machines here, but for machines to actually do their job really well in the field, they have to be trained and more so tested, importantly. So that's a big area. So if
Uh, in Tesla, they use sensors to drive car. If sensors fail, it causes accident, right?
see there is something called sensor fusion. It's not that simple. There is so much with respect to the technology. So what sensor fusion does is, if you have like one sensor trying to identify the distance, it's not just one sensor. You will have a backup sensor and a backup to backup sensor. So you have bunch of sensors. You probably have like 4 5 sensors, and then you fuse them together, and then you have an algorithm, which usually we call that as a sensor fusion algorithm, to basically it's like control system. It's a control system where this sensor fusion algorithm acts as a control system to basically define the orientation, or the orientation of the object primarily. So it's got to do with more than just a sensor. So there is a science of sensor fusion and control systems. So it's not like that if a sensor fails, that this could not work. But what happens is, if an electromagnetic pulse is hit, then these sensors and electronics fail, and that is where it may cause a catastrophe. Anyway, I'm not sure if scientists are working on coming around with that kind of scenario, because that scenario, the probability of such thing happening is very 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 less. So nonetheless, to continue this, this is the AI tree. We covered machine learning, where we didn't cover deep learning. I'll tell you what deep learning is. Unsupervised machine learning, I touched upon the NLP aspect of giving you a demo where a machine can learn all by itself. A supervised machine learning where we saw demo one and demo two. Yeah, actually started with expert systems. These are the legacy systems. If people remember, probably some of you might have read this or studied this in engineering, or maybe sometime later. This expert systems were predominantly used earlier, and the rest of the AI was primarily used in gaming. Gaming was the big thing where AI was predominantly used. But otherwise, AI was usually thought as a useless subject until I remember in '97 when I used to say that I want to specialize in AI. People used to kind of make a face saying that probably I'm heading towards the wrong direction. But nonetheless, then we have NLP, text generation, question answering, context extraction. You saw a demo of context extraction, classification. You have machine translation, which you have Google Translate for that. You have robotics. AI is in robotics. AI used in planning, like for planning supply chain management. AI is being used. In fact, AI is not much there in supply chain management because I've been working on supply chain management as well for past a year, where you make a planning engine. But planning AI is also used for planning. AI is used for vision. We saw that. AI is also used for speech. You have that in your hands. Your handle device, is a speech, text to speech, and speech to text. It's a very common thing. At a high level, this is what AI tree looks like, and we covered vision, speech to a certain extent, natural language processing, and logic is where I said AGI will come in a picture going forward. So definitely AI is glorified statistics. You need lots and lots of data. Uh, this is AI and difference between machine learning. It's AI is more like abstract, and machine learning is more like concrete. AI is more like a superset. Machine learning is as a subset. You can have advanced machine learning algorithms or supervised machine learning algorithms. So, but the debate kind of continues. So, nonetheless, people kind of write AI and machine learning together, AI slash ML. So you don't really have to worry about that. So this slide touches upon deep learning. See the difference between deep learning. Let me blow that up. See, if the amount of data increases, a typical neural network gets saturated. And if you train it more, you will overgeneralize. We'll touch upon what overgeneralization means. Whenever you learn a new technology, you will have a lot of alien words. You will have a lot of new words. So get familiar with these words because if you don't get yourself familiar with them, they will intimidate you. Like generalization is one word. I cannot use any other word apart from generalization, but I can explain what generalization actually is. But it's basically where your if your training becomes huge, then your network is saturated, and if you overtrain it, it can overgeneralize at sometimes. And when it overgeneralizes, it can misclassify the information. So the algorithm might misclassify many concepts into one. But with respect to deep learning, these algorithms are phenomenal in a sense that the more the data you give, the better the performance of those models would be like. So that's the difference between deep learning and older neural network algorithms. So this is particularly got to do with neural networks. With advanced machine learning, we do have algorithms that are very accurate with respect to learning from more and more information. Reinforcement learning is what I said, where the self-driving cars can kind of use it. Uh, this is autopilot,
हाँ इधर
and
कर रहा है मुझे भी अच्छा लगता है फिर रोटी अच्छी आती
uh,
आगे
I
खत्म
hear
करके हजम करके करें
I hear someone speaking in the background. Someone can. Could you please mute the phone, please?
और मजाक सुना
Hello. If someone has unmuted their microphones, could you
ऐसा
please
बता
mute it because I cannot carry on. Thank you. So with machine learning, we saw supervised, unsupervised, and reinforcement learning. So the topic of today of interest was the neural network. It's already about an hour until we reach this slide. So had you had some background knowledge, then probably would have skipped couple the first 10 slides, and I would have moved directly to this neural networks, because that is the topic for today's discussion. But since only one hand raised, I thought let me take you through some of the basics and try to intrigue you with what AI can do, how it does at a very high level, so that you get that comfort feeling. Now, neural networks, some people misunderstand that neural networks is AI. Of course, it is AI, but what they do is they misunderstand that neural network is the only AI. Remember, neural network is a subset, a very small subset of AI. AI by itself is a very large field. You have deep learning algorithms that could be based off neural networks, that could be based off advanced machine learning, where, see, when I say about advanced machine learning, these are algorithms which are completely mathematical, like the singular value decomposition. Uh, that's an advanced machine learning algorithm. That's completely got to do with linear algebra. It's just not got to do with neural networks. You don't have a neural network, for the algorithm to learn. It learns. It's an algorithm. It learns, but it learns a different way. And neural networks learn in a different way. So that's something that you have to, we have to understand that neural network has a different mechanism of learning, and other algorithms like SVD, or support vector machines, or LSA, LSI, latent semantic indexing, latent semantic analysis, which are based off SVD, of course, they learn in a different way. So there are many algorithms out there, and each of them, they have their own way of learning. Let me show you, if I have that slide. You see the slide. You see, there's so many algorithms. If you see the screen, you see this dimensionality reduction. These primarily are advanced machine learning algorithms. They decompose the data on their own and learn from the data by itself. It's called principal component analysis, which is the essence of singular value decomposition. These algorithms have been used for decades. And then you have, there's so many algorithms, rule system regression. Then you see these neural networks, very small part of machine learning algorithms. You know, you have this perceptron concept. So anyway, so I just wanted to see this picture so that you get a feel of where neural networks actually come in. So neural networks by itself is not complete AI. It's a very small part of it. Okay, let me go back to neural networks. Okay, here we are. So, okay, in neural networks, remember in schools, I'll try to relate what we actually know, and then try to connect that to this particular topic so that it might help you understand. Uh, I need, the board to actually explain some of the concepts, but I don't have the, technology to actually write it on a piece of paper where you can actually see what I'm writing. I don't have that provision right now. So I'll try to explain verbally as much as I can. So try to comprehend. If you don't, then that's okay. It's a difficult subject to just listen and understand. So a neural network will have an input to have an output. We know that. Remember in our schools, we used to solve linear equations, and we used to have LHS equals to RHS. How many of you remember that? If you can raise your hands. If you can raise your hands, how many of you remember LHS equals to RHS? Okay, all of you remember. Fine, good. Now, I think most of you will remember LHS equals to RHS. So neural network is something similar to LHS equals to RHS. My RHS right-hand side is my ground truth data. Let me take you through a program. Okay. Now this program, this is a Python program. It's actually a neural network which identifies digits, handwritten digits. It's images. It identifies that. Now the ground truth data for that is here. It's here. I'll open the small, the bigger one is pretty big. So you see this, the first column, A, you see 2, 2, 2, 2. Now the digits following that from here, from B to all the way down is your pixel representation of number 2. You see these numbers? These are pixelated, these are pixel values. These are pixel values. And of course, these are grayscale pixel values. And they are 784 of them. That will be my input. When I say input, this input that you see on the screen on the left side, input layer. This input layer is 784 input. So that's the input that we are giving to this network. 784 input nodes. That will be our input. Okay. And this is what that input is. This is that input. And these are pixel values. These are pixel values. Okay. These are pixel values. So once we query this to the network, we kind of normalize them. Okay, let me show you what that means. Like, let me show you. I have a test data that's a representation of 2. I will just show you that. What it looks like. Okay, this now value 35 in the test data is in here, temp variable in this. So I'll resize this. You see, this is 2. You see these pixel values. These are the values of the pixel. And if you see this, you see, you can see 2, right? This is 2. These are the values. These are the pixel values. So each box that you see here, each cell that you see here represents a pixel value. 0 for white background. So it's a 28 by 28 matrix. That's the dimension of this image, 28 by 28. Okay, that's what it means. So this pixel values that you see here is the first row that you see. All these values in the first row represent this particular image. It's only that this is 784 values linearly plotted or linearly written in a CSV file, and the ground truth for that is this 2. So all of these values starting from B to wherever it ends, okay, ADE, they represent this 2. So I know my RHS, my right hand side is 2. I know that. Okay, now this is the data I'm giving to a neural network, and these are the weights. This is the hidden layer. The hidden layer for me in this particular demo is is in here. So my hidden nodes also are 784. There is a reason why I've written that. Usually they are less than half of your input nodes. It could be 500 or 600. I would keep it like 200 or 300 max. But for the demonstration purpose, I've kept it 784 for some reason. My output nodes is 10 because I am training this network to identify 10 digits starting from 0 to 9. 0 to 9 is my 10 digits. That's my output, which is this. My output. Here you see 4 output. Output layer has 4 nodes. So in this case, my digit identification network has 10 nodes starting from 0 to 9. That's what it identifies. Okay, now we've covered this data. This is a ground truth data. So this MNIST data set that you can see, you can download this MNIST, MNIST. You can download this. It's a training data for identifying digits. You can download this from the web. You also have test data and you have the training data. The training data is used to train the network. The test data is used to test the network, where we know what the output is, but we want the network that is learned from training to identify what that is, and it'll have a performance, efficacy, or trying to figure out the sensitivity or specificity analysis, where we see the performance of the network, how accurate that is. And then we query the data. So usually if you have the training set, you basically keep 20% as a test data, take 80% or 70% of it to train the data, and then probably keep the 10% to query the data. So you can do that. So that, anyway, let's not get into the engineering aspect of how you kind of train and query the network. We'll try to understand what's actually happening within the neural network, which is the focus of topic is, we know the RHS, we know the ground, we know the output of. Now, when I give these kind of pixel values to my network, I have 784 input nodes. If I give those values to my network, then my network must identify them as 2. Okay, I'm training my network to identify, these 2. So I've already done that. I have trained that. I can train it again. Let me train that again.
This is a neural network designed to identify numbers. Reading the training set that will be used to train the neural network. Moving ahead to train the neural network with ground truth data. Training the network is completed in 0 seconds. Moving ahead to test the neural network with test data.
It's going to take a while to, because our training set is very less. It's only 4,
Finished testing the neural network in 12 seconds. Performance of the neural network is
now you see the performance is very
10.32%.
less. It's only 10.32% because we trained the neural net only with identifying digit 2. And this is our training set. It's very small. It's only 4 ground truth. That's a data. Statistically, it's very weak. And also statistically, it's wrong because we only train the network with digit 2. We didn't train it with 1. We didn't train it with digit 3, digit 4, digit 5. All those are missing. Remember when we were having a look at demo 2, I mentioned that when you are training the data, train it well, it was misclassifying the donkey as a horse, because obviously they didn't train the network with a lot of donkey images. So the network was not able to classify the difference between a horse and a donkey. So when you give a horse, when you give a donkey as a query, as an input, image to the network for the network to identify, it will misclassify that as a horse. We'll see that in a while. We trained this only with 2, we'll go back to our network and we will query um, 35. We have a training set already. It's a bunch of array. It's an array. It's an array like, no, this is not the right thing. It's an array where, okay, let me show you that. This is the test data, right? Let it open so that I don't confuse you. So see, the first array or the first row in the CSV file is 7. This is the ground truth data. Then the digits representing, from B until the end, which is like 784, is a representation of number 7. So similarly for 36 here is 2. So if I'm using my Python programming language, my index starts from 0 to 0, so it's 35. So I'm querying 2 to see if this network identifies 2.
The digit identified is 2 with an accuracy of 95.0%.
So see, this is the image that it was able to identify, which is 2. It accurately identified, although the data was less. It identified with an accuracy of 95%. Let's see what happened within the network. This is what I wanted you to see within the hood, because most of the people in AI treat the hidden layer as, or the network itself as, a black box. So let's try to, look into what that actually looks like. Okay, so this is our input data. This is what we gave the network as an input, and this is a normalized data. What you saw earlier was the actual pixel values. See, I normalize this. You see this too? So earlier you were able to see the pixel values of this network, which the pixel values primarily, if it's a grayscale, range from a value of 0 to 255, if I remember it right. Yeah, 0 to 255, 255 being black and 0 being white, if I'm correct. I may be confusing, but that's how it is. If it's a grayscale value, it ranges from 0 to 255. So what we're doing is we primarily normalize. When we give this an input, this is the input to the network. We are not giving these actual values, 254, 250, 240, 228. We don't give these values. We normalize these values. When we say normalization, it could be min-max normalization, which is commonly used. You can Google some of the algorithms for normalization. We do this because we want to keep the complexity as small as possible. Remember, when we used to solve mathematical problems, the first step was simplification. Take the problem, simplify it as much as possible, and it becomes easier for you to solve it. So that is also true with neural networks. You simplify. But how do you simplify them? By normalizing or flattening the data. You also call as data flattening. You can note down those words. So here we normalize the data in the range of 0 to 1, so that our managing or learning becomes faster and easier for the network. So it becomes easier. So this is the input we gave. You see, these ones are actually black colors. They're actually 250, 255 grayscale values, 0 being white background. So this is what we gave to the network. This is the input. Okay, my output weights. These were my output weights. You see, my output weight, except for all, the second 0, 1, 2, this is number 2, is 2.95. This is the highest, which means the number identified is 2. You see here, with accuracy of 0.95, which is my final weights. My final weights are these. How many of you remember electronics lab, if you've gone through engineering, wherein we used to have encoders, 10 to 4 encoders? You can raise your hands. How many of you remember encoders and decoders? So here we have an encoder which will encode 784 pixel values into 10, 10 values to identify what those representation of numbers are. In a nutshell, a neural network is okay. Let me give another analogy. If you're not able to comprehend this, let me give another analogy. A signature is an identity of a person. Every person has a different signature. Some people have. I just saw someone raising their hands. You want to ask some question? Okay, let me continue then. See, a signature. Every person has a different signature, and some signatures are very difficult to comprehend what the name could be like. I mean, a person's name might be, Abdul Rahim, but the way he signs, if you look at his signature, you will never be able to identify what his name actually is like. So that is actually true with neural networks. In neural networks, I know my ground truth data, I know my output, but these weights that you see here, they adjust themselves. How do they adjust themselves? Something called back propagation, where you know the output, and since you know the output, the value that will be coming here. Initially, these weights are all random weights, ranging between 0 to 1. You will have these weights. So in the range of 0 to 1, primarily when you start the network, you will give some random weights to them. You kind of randomly initialize the weights in the edges, and then what you do is you see the output. If the output is not in sync with your ground truth data, you know the error that you're getting in the output, and then you back propagate that error so that the weights adjust, which is why I said LHS equals to RHS. I know my RHS value, and then I correspondingly change my LHS values so that they have to be same. My output is 2, which means my weights representation of my RHS must be equal to that. That's exactly what a neural network is doing. It's LHS equals to RHS, where my LHS is my network weights and my RHS is my ground truth data. So I know my RHS, it's easier to factor my LHS. Now, how do we factor that? We factor the weights in the neural network, where these weights are adjusted for a given digit in this case, in this particular use case. So it's more like a signature of 2. So since we've trained this network on identifying number 2, digit 2, this is my weights in the hidden output. This is the representation of my weights. You see this 28 by 28 matrix again. So this is a signature of the data that we actually gave in. This is unique for 2, and this will be unique for 3. It'll be unique for 4. It'll be unique for digit 5. That's how a neural network will be able to identify different digits. That's the idea. That's the idea. This is a signature pattern of digit 2. I just want you to understand this hidden, these actually the weights, the output of the weights. See, the weights will be here on the edges, and then when you pass that in, I'll not get into the complexities of sigmoid function, the back propagation, the epochs. I'll not get into those terminologies because that might confuse you. I want to keep it as simple as I can. You have your RHS, which is your ground truth data. You know what the data is. You know what the output is. I actually showed you here that my output is 2 for this given pixels. And then I somehow have to convert this input into weights, wherein those weight representation will actually match the digit, which is the RHS, which is my ground truth. If I do it right, and if I generalize it right, uh, then this network will accurately identify the various digits. Now we saw that it was able to identify this digit 2 accurately, but let's try a different query. Since we've trained this network only with digit 2, it will not do a great job. I have 30, which is this. 30 would be 31, 3. So this is 3, training data 3. So we are trying to recognize digit 3, and this is the input for that. Let's do that.
The digit identified is 2 with an accuracy of
You see,
95.0%.
it's misclassifying this particular input to also be 3. This is exactly what happened with that donkey example, where we gave an image of a donkey and it misclassified it as a horse. So similarly here, since we have trained the network only with number digit 2, we also give digit 3 for it. And now we know that the network is not trained to identify digit 3, but still we gave digit 3 and it is misclassifying that as digit 2. So here is the takeaway, that when you kind of design a network, make sure that the data that you give is comprehensive. You're covering all aspects of your input data. You're not missing on any. If you do that, it is apparent that the network will misclassify some of the unknown input data, which it is not trained on. So that's the takeaway. So we know that, and if we also saw that the accuracy, the performance is 10.32%. It's not great. So let's train this network on a bigger data set. I will train this.
Yasin bhai, sorry for interrupting here.
Go ahead.
So we just, this is Muhammad Azad. Okay, so we just have another 13 minutes left. Can we go from the career perspective so that some of the participants here might be getting to know about who should get into this field and how to get themselves prepared? You have kind of, sorry, I should have given, really appreciated you for all the presentation you have given and creating an interest in this field. With only a few minutes left, should we get into that mode of discussion that might,
Yeah, yeah.
you don't mind?
We'll do
Sorry
that.
for interrupting
I
here.
don't mind. I don't mind. I
I
don't
hope
mind.
that should be fine with everybody. So I have few questions. If I can go ahead, I just wanted to give a new dimension to the last 10 minutes.
Yeah, sure. Let me do this. Give me 2 minutes. What I'll
Yes,
do
please.
is, we train this network on a very small data, which is this. Okay. What we'll do now is we will train this on a bigger data set, which is this. This is a bigger data set. It has about like 50,000 rows, and it covers all the numbers. So the training will take some time, and in the meantime, we can actually proceed with the session that you were just talking about. So I'm just giving that source for the network to train, and my number of just a second. Departures is true. Okay, let me keep it to for the time being. Fine. So let this train, and we'll see that.
This is a neural network designed to identify numbers. Reading the training set that will be used to train the neural network. Moving ahead to train the neural network with ground truth data.
You see, it started training on various digits, so we can continue with you wanted to say something.
Yes. Thanks, Yasin bhai, for accepting my request. I thought, because we only have 10 minutes left, so it should benefit some of the people who are interested to look at a career opportunity in this field, actually. So my first
Yeah.
question, I have a set of questions probably that might help everyone here. So I have also heard of C++ as a one of the programming language which can be used vis-a-vis Python. Okay. So what is your suggestion about C++ versus Python for this field? For this field.
See, Python has very matured libraries with respect to AI. I mean, Python is a programming language. Again, AI is not got to do with any programming language. If you ask me, it's all got to do with math. As long as you know the math, you can program the algorithm in any programming language if you want to. I used Java for a very long time because we didn't have Python then, in 2006, in 2003, uh, I used to write my code in Java to implement the AI algorithms, and it was very difficult because we didn't had APIs.
Okay.
We have some
Yeah, I
background
wish others
noise.
can go on mute, please.
Uh,
Yeah,
okay,
go.
uh, so we had Java then, and it was difficult because we didn't had APIs like Python. If you had to do a Java program to implement SVD, it will be a mammoth task. And in Python, it's just one line of code. I don't even have to implement the algorithm; it's already implemented. So you have to make a choice. If you're going with C++, primarily you would go with C++, where the performance is a concern. Like if you're using Arduino Uno or Raspberry Pi microcontroller, that is when you go with languages like C++, just because you want that speed. The speed becomes a factor. So you decide upon what specific problem you're trying to solve. And if performance is of huge importance to you, then you basically choose C or C++ and work on that, implementing the algorithm. Because if you're using Python and other programming languages on microcontrollers like Raspberry Pi and Arduino Uno, which hardly have 1 GB of RAM, uh, that is where you actually deal with making such a situation, making such a decision where choosing a programming language becomes important. But if using a GPU, then Python is absolutely fine, because you don't have to worry about the performance. It's on server, it can run on GPU, it can solve problems for you. Would that answer your question? Hello.
That answered my question, Yasin. But so there are tools like this TensorFlow, PyTorch, and all. Could you please quickly brief about that to the audience?
Yeah. See, I have another demo on TensorFlow. I thought I'll take you through this, but we do not have time for
Yeah,
this.
yeah. If you
Uh,
could tell them what it is all about, and all.
yeah, I'll tell you. See, here in this program that you see here, it's all hard coded. I mean, hard coded in the sense we have to manually code the entire network, the hidden layers, the output nodes. So it's not encapsulated. It's all that you write. You do the math yourself. You use the lambda function, which is the activation function, the sigmoid function. Of course, with Python, it's the complexity is reduced because we're dealing with matrices and multiplication. All that becomes easier. But still, it's a little bigger program. And we're doing normalization, everything here. But if you're using TensorFlow, we're using a TensorFlow library, if you see here, my program is so small. It'll do the same thing and better and faster.
Okay.
Just a couple of lines. So much of the engineering work is encapsulated. If you see these two programs, you will be able to make the difference. TensorFlow is encapsulating the neural network complexity. We just, worried about my input data. I basically give this my labels. This is my training data, and this is my test data, and this is my sample, and and then I basically use my linear classifier.
So
And
basically, TensorFlow helps to simplify the whole approach about.
TensorFlow helps the engineering part of it.
Okay.
It's only the engineering part of it. It's but if you're trying to solve some real problem, as I said, understanding the problem itself is challenging. So
Okay.
if you don't understand the problem in its entirety, then TensorFlow is just a tool. How will use a tool if you don't know how to use it?
Yeah,
That's
correct.
the idea.
Okay. And how about PyTorch, Yasin?
PyTorch, I might not be the right person to
Okay.
comment on that, because I really have not used PyTorch.
Okay.
I've used TensorFlow, I've used Python is what I primarily use. Python and Java programming, because I specialize primarily on NLP, natural language processing.
Okay, okay. How about this getting OpenCV skills also?
OpenCV skills is important because if you're getting into image processing, the default library that is used predominantly is OpenCV. So, and OpenCV is very matured. If you use this particular library, if you know how to use it, the engineering part of it, using the API itself, will
Okay,
uh, will take you a long way through, because it also helps you understand, how things work in real world, how these things are trained using OpenCV. In using OpenCV, you can also train the network to identify new objects. So much of the complexity with respect to convolutional
Yasin, we lost your.
workspace and
There was a
what
break in your
you will
voice.
if using such WAN. The network is unstable. Am I back?
Yeah, yeah, you are back now. Yeah,
Am I back?
yeah, you are back. You are back.
So yeah, OpenCV is a good place to start if you're interested, focused on image processing problems.
Oh, okay. Image processing. Okay, that answers the question well. So another very interesting question, Yasin bhai, maybe it might be running in most of the people's mind on the lighter side. While doing the engineering, completing the engineering, the biggest task is clearing all the engineering mathematics papers. Okay,
Hmm.
so that's the biggest task, okay, for
Yeah.
everybody. So should I be really good at mathematics if I have to get into this field? A very
Uh,
basic question. A very basic question I'm asking.
yes, you have to be very proficient with statistics, math. This is the part of mathematics that you see on your screen.
Okay.
Okay, this is sigmoid
So
function.
friends,
It's activation function that you see
yeah,
on
so
top.
I think our friends who are interested in this six topics you are listed out here, linear algebra, calculus, I think everybody gets a jitter when they see all these tight topics actually,
Uh,
particularly the
uh,
probability theory.
no, actually, these are very. I'll tell you what. We were taught math in schools and colleges and our engineering as a subject, but
True.
we were never taught to actually appreciate the
Applications,
subject,
applications.
because yeah, see, without math, you can never comprehend AI.
True, true, true.
You can never solve these problems without math.
Correct.
And if you get to know how math is actually helping you solve these problems, you will start appreciating the beauty of math.
Wonderful.
So since it's complex, it's actually not complex. If other people can understand, you definitely can understand. We definitely can understand. It's just a matter of putting that effort. Riding a bicycle is also difficult, but if you enjoy riding a bicycle, it makes fun to learn riding a
Absolutely,
bicycle, right?
absolutely, yeah.
So math is no different. If you really love math, math is. I mean, I've come across people who love math. They wake up. I mean, I know this person who's a mathematician. He has close to 100 patents. He wakes up 4 o'clock, 4 a.m. early in the morning, and he spends 2 hours solving mathematical problems. I mean, he's a senior guy. He's been a vice president of a company,
Okay.
and he's also was my boss at some time.
Okay.
He was passionate about math. I mean, his job had nothing to do with math, but
But he
he
was
loved
loving.
math so much that he
So
always used to
some
spend
people
two
do
hours.
like some people do love a lot of number crunching. I mean, they may not be interested in the real equations and all, but now the number crunching people are very interested actually.
This has got to do with solving real world problems. Remember when I started the topic, when I started the presentation, I said it's all got to do with understanding the problem and formulating it mathematically.
Correct. You're right.
Seeing the problem mathematically. When I say formulating the problem mathematically, it is actually looking at the problem mathematically. When I see a real world problem, I need to mathematically equate it. I need to write an equation, mathematical equation, what the real world problem actually is, or at least understand what the real world problem is.
Good, good. So
If
I
I
have
don't,
lost. Okay, thanks, Yasin bhai. Sorry, I moved to the next question. Uh,
Mhm,
let's say I have completed my engineering this year, BE in computer, Bachelor of Engineering in Computer Science, and I
mhm,
have no clue of this field at all. What should I do, to get into this field? Maybe there may be many people who are fresh engineering graduates passing out this year, maybe. So
mhm,
if I have to recommend somebody, or if I have to do something, I'm a fresh engineering graduate coming out of computer science or electronics. What should I
mhm.
do now to get in this field?
Uh, See, first of all, I would say if you're in your engineering, you start focusing on these subjects earlier. You get into these subjects, the better. And if you didn't had a chance to that, or if you didn't have any guidance with that, you just finished your engineering, try to focus on these. Typically what I've seen is engineering graduates come out and I think if they learn Python, they will get a job in data science. That's not true. uh, if you're not familiar with these subjects that I've put on the screen, the linear algebra, non-linear algebra, calculus, if you don't get familiar with these, it's very difficult to comprehend AI. What you can do is you can get into data science jobs like ETL, where you do data pre-processing. Uh,
So more of data engineering, you
and
mean more of data engineering than data science.
You can get into data engineering part where you can start your career with that. The ETL process that they say, uh, you know, uh, what is that ETL process? You can start with as an ETL developer
Mm-hmm.
where you do a lot of data engineering, and then gradually move into data science.
So one last question, Yasin bhai, is that somebody, let's say, is working in a web development field and really gets aspired or inspired by something like this. I want to move into AI. So what is your recommendation about it? Let's say somebody with 2 years of experience in the web development or developing some Android applications, but suddenly gets inspired. I want to be into this field. What would be your advice?
Okay, listen, this is a very serious note. See, most of the people who want to get into AI is because of the salary. This is a real world things that I've experienced. When people get to talk to me and they ask about AI, and people are asking me from commerce background, they want to get into data science. I said, "Do you love math?" That's the first thing I asked them. Do you love mathematics?
Wonderful.
And if you don't love mathematics, I tell them don't get into it because it'll be very hard for you to really comprehend AI. If someone is into web development who is good in the front end development, kindly Google. The usability experts will be of high demand going forward.
Okay.
Usability will experts will be of high demand. High demand, what you call professional, what you call the future prospects for high demand jobs is one of the jobs is usability expert. Focus on usability. If you're a front end developer, if you're good in Android, if you're good in web development, the front end, if you're good in what you call the JavaScript, the JSS, and the Angular, as they say, focus on usability. Try to do specialized courses in usability because there's a lot of creativity. Usability is not just designing a screen. It's got to do with a lot of analytical skills that are not taught while you're actually learning JavaScript or JSS or Angular. It's a different science altogether. Focus on usability. Focus on being a usability expert. That's a high demand job. But if you're getting into AI
Oh,
just
okay.
because you will get a better paycheck, then don't get into it. Unless you're interested, unless you're really passionate about learning new things, learning math and trying to, I mean, it takes a long time. Even if you start with math, it takes a long time. It takes a long time. I've been into AI, Alhamdulillah, for more than 15 years now. But to be honest, I'm still learning. What I know is very, very little. What I don't know is so much more. So every day is a learning for me. So as long as you enjoy learning, then AI is good for you. If you if math intimidates you really, then you have to give it another thought. It's I mean, you enjoy your life. It's not that you just for a better paycheck you uh, that's where I leave it. You
Okay,
decide.
okay. And then, so thanks so much, Yasin bhai, for patiently answering my questions. But I do have a few more questions lined up. But however,
Sure.
as the time is, have already crossed the limit, like I would want you to answer some of the questions which others have already posted on the chat box. Maybe I shall catch up with you later on a personal one-on-one later.
No, no problem.
Thanks so much. Thanks so much, Yasin bhai, for being patient about answering my questions. Jazakallah khair.
Okay. Any
There are a few
other
questions in
question?
there are a few questions in the chat box. Probably is put forward to you.
Yeah, yeah, yeah. I'll read one. Okay. Okay, someone is asking for source code, and okay, and I hope I'm glad that it helped at whatever level, because covering a complex topic like this in just 1.5 hours is really difficult. I just wanted to check, when maths is referred, will it be anything extra maths to be learned? It's basically this math that I actually put across on the screen. It's only that you get a hands-on and refine it with respect to solving real-world problems. The problem with the math that we learned in our engineering and school is that uh, it was not related to real world in a sense that we could comprehend or think mathematically, which is why when I started this presentation, I also mentioned you to Google Stanford space how to think mathematically. Stanford space how to think mathematically. Stanford University has started a curriculum. You can download that, and that curriculum will actually teach you or walk you through how to think mathematically. So having known these subjects, the mathematical subjects, it's also important to apply them. So applying them will, that is where this how to think mathematically subject will help you. Okay, you want slides for this, and then anyway, this is a recorded session. You will have access to the slides in the video that you actually will see. Um, Okay, Bhai, what is the background and how weight are adjusted in a network? Okay, to answer this, let me reiterate. I needed, some pencil and pen to actually show you, to write it down, to back propagate and show how this things works. I didn't have the provision to do so. But what I said was, remember, LHS equals to RHS. I know my ground truth data, which is my RHS. My LHS will be my weights. Now, my weights have to be tuned uh, to represent my output, represent my ground truth data. And we you basically design the network mathematically so that these weights are adjusted given the error that you find it in the output. You know the output, which is 2. But if my numbers are different, then I know the error. I back propagate the error to adjust the weights. Now, this becomes difficult for you to comprehend when I say back propagate. That's a new term, and how that will adjust the weights automatically also will be difficult for you to understand that. I think probably we can focus on another session where I basically walk you through uh, the way in which a neural network works, and then touch upon why it works. I think that would be a better one, where you can actually, maybe in the next session, we'll try to understand this deeply. I'll prepare the slides accordingly so that, I'll answer that question. But that's a very valid question. That's a very valid question. Okay. 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 Saif Bhai has uploaded the recording as well. So any other questions? I see my network is still training. Anyway, it takes time. That's why they use GPU machines to train networks. This will take some more time, maybe. Probably I shouldn't have given that print statement. Would have been faster. Any other questions you guys have?
Yes, actually, the today's world you are telling that AGI. So the logic trainings, like actually it can. So you have a training, the voice as well as mathematics and everything in place. So to
Mm-hmm.
make it in sequence, you need to have a logic. Okay, so
Mm-hmm.
if a AI machines or robots can do the logic on their own, does that makes yeah, that will be challenge for humankind, or so what do you
It it will be. It will be. See, singularity is something that they call where the AI will surpass human intelligence, which is a myth at this point of time. Uh, but that's also a concern because AI is progressing so fast. It's actually progressing exponentially faster than we can even comprehend. So the logic part is difficult, but if you reverse engineering the logic of how we humans interact, because we have lots of data to reverse engineering that, as I mentioned, the names of Facebook and Google, these people have so much of data of how we interact, how we write emails, if they have access to our emails, you know, uh, and they can use that form of interaction to reverse engineer. In fact, Google has released the latest Lambda. Can you please Google Lambda and see? This is the API where a machine actually talks like a natural human being. I mean, I was amazed when I saw that because 2, 3 years back, this was impossible to develop an NLP that can mimic the way human will talk to. I mean, we have Alexa that talks like a human being, but that makes mistakes. But this Lambda is much more powerful because when you develop,
Training the network is completed in 13-15
okay,
seconds. Moving ahead to test the neural network with
okay,
test
now the
data.
network has trained on the data. Now it's kind of trying to measure the performance. Anyway, we continue. So AGI is all got to do with how do you bring this.
Finished testing the neural network in 12 seconds. Performance of the neural network is
You see the
96.86%.
performance was 10.32% earlier, and now the performance of the network is 96.83%. To bring you that query that we had, the query 30, which was number 3, will it identify number 3 now, because it was misclassifying that as number 2.
The digit identified is 3 with an accuracy of
You see that earlier it was
100.0%.
misclassifying that as 2, but now we have an accuracy of 100%. It's 3 because we trained it with lots and lots of data. So anyway, getting back to this question of AGI, see, AGI is a researched field. Much of this research is happening in closed doors in big companies. But yes, if AI is not regulated, then AI could be a threat to human beings going forward. That's the way I see it. It might be very subjective, but that is how I see it, because I do understand uh, at some level how these machines work, and that kind of concerns me as well. Any other question?
Hi, Yasin. Shoaib this side.
Ji, assalamu alaikum. Go ahead.
Yeah, yeah. So I have one question. Like I have been trying, I have been learning, and I have been doing. So I have been trying for NLP, going to. So like how we can break into this field actually. So the problem is that if you go outside in the world, like most of the people will face this problem. Like they ask for relevant experience. So we don't have relevant experience. I learned it by myself, and we are doing it hands on and all these things. So how can we break this cycle and go into that?
Yeah, focus on the job that you currently are in, and then you know what you do is you start focusing on these subjects that you see on the screen, and then try to come up with some try to solve some real world problem. It could be a very small problem. Try to start solving this problem like a hobby. Do your regular job. After your job, you can come back. That's how I also started with AI. I used to do my regular job, get back home, do stuff that I like to, with respect to AI in particular, and solve some problems. And that's how you start learning. You kind of self-learn that. You don't have to MS and PhD. If you're not privileged, if you're not privileged to do that. If you're privileged to do MS and PhD, I would recommend that you go ahead and do your PhD in AI, because AI is a lot of learning. But if you can't do that, then you do your regular job, come back from job, spend 2 hours, 1 hour, 3 hours, whatever you can, whatever you can afford, but you do it every day. And maybe in a matter of a year or two, you will get a hang of the subject. You'll get a hang of a subject, and you will know where exactly to proceed and how to basically look for information and learn on your own. And once you've done that, you will have that confidence, and probably if you have solved some problems, the company will be more interested in looking at what you've actually solved. Okay, and that will actually reflect your knowledge in AI. And once they see that, they will appreciate, and probably they will hire you, inshallah.
Sure, Yasin. Thanks.
So any other subject before we leave? I wanted to ask you one thing. uh, if you have gone through some of the information on AI on the net, if it was difficult, the reason I asked that is that would it be helpful for you to actually go through AI step by step without worrying about the math, because the math will be covered in some form of a blog or some form of a book? Because inshallah, I am planning to come up with something like that that can help people understand AI in a better way, at least to get started with the basic foundation of AI. Would you be interested in referring to such kind of material? If you are, you can just raise your hands.
Yes, and my regular blogs will be extremely helpful, starting from basics and going on to the medium and advanced level.
Okay.
So blogs will be really helpful, inshallah.
Inshallah, let me then plan accordingly. I know Dr. Saif has been telling me to come up with some kind of a material where we have regular AI sessions that we can cover. It's only that I was too tight with the time. But let me try to focus on this as well, and try to do something around the space, because it's also a learning experience for me, and something also that I think I enjoy. So Jazakallah khair for hearing me out. It's definitely a learning experience for me, and I'm not here to teach. It's rather to learn. Every time I give a session, I learn. So it's a never-ending story. Jazakallah khair for all of you.
Jazakumullah, Yasin.
Jazakallah khair.
Thanks a lot
Assalamu
for
alaikum.
taking this very informative session, and thanks to all the participants also for joining and for making it more interactive and lively. So inshallah, keep joining every weekend, inshallah, to these sessions, and also invite your other friends and colleagues and relatives so that they also get upskilled on the latest technologies. Okay, with this, we close this session, inshallah. Assalamu
Yeah.
alaikum.
Wa alaikum assalam wa rahmatullah.